By the middle of the Second World War, the Pacific Ocean had become both a battlefield and a graveyard. Every island captured by American forces came at a staggering human cost. The battles for Tarawa, Saipan, and Peleliu revealed the same pattern. Victory on land brought with it an ocean of wounded men with nowhere to go. Beachheads were littered with stretchers. Makeshift field hospitals overflowed within hours. The tropical heat turned wounds septic, and the distance to established bases meant that even survivors often died before reaching proper medical care. The scale of the suffering exceeded every logistical calculation made by the U.S. Army and Navy medical branches. It was a problem of distance, time, and human endurance. The American medical evacuation chain had been designed for Europe, where hospital trains and nearby rear bases could handle the flow of casualties. But in the Pacific, distances stretched beyond imagination. From the beaches of the Marianas to the nearest hospital on Pearl Harbor or San Francisco lay thousands of miles of open water. Even with the fastest transports, evacuation could take weeks. The Navy's existing hospital ships, such as the USS Solace and USS Relief, were indispensable but too few. Their decks were filled to capacity after every major landing, and each voyage back to the mainland left entire divisions without immediate medical support. On the front lines, doctors performed amputations by lantern light, while corpsmen used captured enemy barges as floating wards. It became evident that no number of doctors could compensate for the absence of ships. The industrial power of the United States had always been its greatest weapon, and now it was called upon not to destroy, but to preserve. The Naval Bureau of Ships and the U.S. Army Transportation Corps began searching for vessels that could be converted quickly. Shipyards along the coasts were already building destroyers, carriers, and landing craft around the clock. There was no capacity for entirely new hospital ships. Yet the nation had one resource in abundance: the humble Liberty ship. These standardized cargo vessels, mass-produced since 1941, had kept Britain and the Soviet Union alive through the worst years of the war. By 1944, hundreds were idled or awaiting reassignment. To an engineer's eye, their simplicity was an invitation: a steel shell large enough to hold hundreds of beds, with engines reliable enough for transoceanic travel, and a structure that could be gutted and rebuilt almost overnight, not for combat, but for care. In Washington and Pearl Harbor, quiet orders circulated through the shipbuilding bureaus. Selected Liberty and Victory hulls were marked for conversion. Some had already served as transports or freighters, others had never left port. For naval architects, the challenge was not whether the transformation could be done, but how fast it could be achieved under wartime pressure. What emerged from this decision would become one of the most overlooked engineering feats of the war: a fleet of hospital ships born not from new construction, but from repurposed lifelines of the Allied supply chain. Their creation represented a subtle but profound shift in the philosophy of war production. The same standardized steel that once delivered ammunition would now deliver survival. As shipyard workers stripped the decks of old cargo fittings and laid out blueprints for operating theaters and sterilization rooms, they understood the urgency of their task. Every day a ship remained in port meant another convoy of wounded men waiting under the tropical sun. The transformation of cargo hulls into hospital ships was not driven by innovation alone, but by necessity. It was an act of engineering triage on a national scale, a moment when American industry turned its precision and efficiency inward, away from destruction, toward mercy. The project had no single inventor and no headline victory, yet its impact would echo across oceans. The floating hospitals that emerged from those steel skeletons would carry thousands of soldiers away from the front lines, proving that even amid the machinery of total war, compassion could still be engineered. The crisis reached its breaking point in 1944, when American forces began the great amphibious assaults that would define the final phase of the Pacific War. On the beaches of Saipan, Guam, and later Leyte, the United States landed tens of thousands of men within days. Each of those operations followed a brutal rhythm. The first wave secured a narrow perimeter, the second brought supplies and heavy weapons, and the third carried the wounded back toward the sea. Within hours, the landing zones became hospitals of desperation. Casualties lay in rows under makeshift canvas roofs, and corpsmen worked knee-deep in sand and blood. The tropical heat accelerated infection, flies swarmed open wounds, and medical teams ran out of bandages, plasma, and morphine before the first nightfall. The wounded who survived the initial assault often faced a new enemy: delay. The Navy's hospital ships had performed heroically since the early years of the war. The USS Solace had rescued hundreds during the attack on Pearl Harbor and later served off Guadalcanal, while the USS Relief and USS Comfort rotated between Hawaii and the forward bases. Yet by 1944, these ships were stretched far beyond their design limits. A single Solace-class vessel could carry roughly 400 patients, but during the island campaigns, the casualty list from a single division could exceed 10,000. The gap between medical demand and available capacity became unbridgeable. Even when hospital ships did arrive, they faced days of waiting for safe passage or space to dock amid the chaos of invasion. Evacuation flights by aircraft were not yet possible on a large scale, and most of the Pacific's airfields were either under construction or under fire. The only viable route for the wounded lay across the sea, a voyage of hundreds or sometimes thousands of miles to established hospitals on Oahu, Espiritu Santo, or the U.S. mainland. Standard troop transports were occasionally pressed into medical service, but their holds were dark, unventilated, and wholly unsuited for surgery. The lack of sterilization and air circulation turned many of them into floating infirmaries of infection. Men who had survived enemy fire died quietly in the cargo decks, not from wounds, but from sepsis, exhaustion, or simple neglect. The medical corps of both the U.S. Army and Navy began issuing increasingly desperate memoranda to the War Department. Reports from the Surgeon General's office warned that mortality rates among evacuated wounded were rising. Supply convoys could deliver weapons faster than the wounded could be returned to safety. Commanders in the field were forced to make impossible choices: either keep their doctors ashore, risking bombardment and disease, or load them onto transports without equipment. The Pacific had become too vast for conventional logistics, and medicine was losing the battle against geography. Behind the front lines, the industrial bottleneck was just as severe. American shipyards were producing record numbers of destroyers, carriers, and landing craft. Every available slipway was booked months in advance under naval priority codes. Hospital ships, which required specialized interiors, refrigeration, and power systems, were slow to build and offered no tactical advantage in combat. They saved lives, but they did not sink enemy ships. For bureaucrats allocating resources, that made them a lower priority. The result was a quiet but devastating shortage. By the time of the Marianas Campaign, the Navy had fewer than a dozen fully equipped hospital ships for an entire oceanic theater. The problem was both technical and moral. The United States had mastered the art of mass production, yet its soldiers were dying not from lack of firepower, but from lack of recovery. The machinery of war had outpaced the machinery of mercy. Cargo vessels stood idle in anchorages, stripped of cargo, awaiting orders or disposal, while the wounded waited for beds that did not exist. Engineers, shipwrights, and medical officers began to look at these unused hulls with a different kind of imagination. The problem before them was no longer one of combat or strategy. It was one of time, distance, and human endurance. Somewhere between the vastness of the Pacific and the narrow space of a hospital ward, a new kind of ship had to be invented, not to fight the war, but to save those who had already fought it. When the United States entered the Second World War in December 1941, its shipbuilding industry became the largest in history. Between 1941 and 1945, American shipyards launched more than 2,700 Liberty ships, standardized cargo vessels designed for mass production. Built in assembly line fashion at yards from California to Maine, a single Liberty could be completed in less than 6 weeks, sometimes in under a month. Their simple design, triple expansion steam engines, welded steel plates, and a box-like hull, was meant to prioritize speed and utility over elegance or endurance. These ships were the arteries of the Allied supply chain, delivering weapons, food, and fuel to Europe, Africa, and Asia. By 1943, however, The same industrial abundance that had won the Battle of the Atlantic also created an unexpected surplus of hulls. Hundreds of Liberty and newer Victory ships sat idle in anchorages, waiting for reassignment or conversion. At the same time, both the U.S. Navy and the Army Transportation Corps began to recognize that the very qualities that made these vessels efficient for cargo transport also made them ideal for medical conversion. Their internal layout could be stripped of bulkheads and reconfigured into wards and operating rooms, and their reliable engines could power refrigeration units, surgical lighting, and air conditioning systems, luxuries almost unknown in wartime medicine. The idea was not entirely new. During World War I, the U.S. and British navies had converted passenger liners into hospital ships, but those vessels were few, expensive, and vulnerable to submarine attack. In 1942, as amphibious warfare expanded, a new generation of hospital ships was needed, compact, standardized, and capable of reaching isolated battlefronts across the Pacific. The first conversions of Liberty hulls began quietly under the Army's control. In 1943, the SS Zebulon B. Vance, originally a cargo ship operating on the North Atlantic routes, was transferred to the Army Transportation Corps and refitted as a hospital ship at the Bethlehem Fort River Shipyard in Quincy, Massachusetts. When it re-entered service in 1944, it bore a new name, USS John J. Meany, and a new purpose. Its cavernous holds had been transformed into wards capable of treating over 400 patients, with surgical theaters, sterilization rooms, X-ray equipment, and refrigeration units for plasma and medicine. Around the same time, the SS Samuel F. B. Morse underwent a similar transformation at Todd Shipyards in New York, emerging as USS Jarrett M. Huddleston. By the end of 1945, a total of 6 Liberty ships had been converted for Army medical service, each carrying between 400 and 500 patients. These ships operated under the Red Cross emblem and were protected by international law as non-combatants. They served routes from the Philippines and New Guinea to Hawaii and San Francisco, transporting tens of thousands of wounded soldiers back to safety. Unlike the Navy's larger Haven-class hospital ships, built from the ground up on C-4 hulls and capable of accommodating over 800 patients, the Army conversions were temporary solutions, but efficient ones. They represented a hybrid between improvisation and industrial planning, a reflection of the United States' ability to redirect its vast production system from destruction to recovery. The decision to use standardized cargo hulls had another strategic benefit. It allowed shipyards to avoid interference with ongoing naval construction. The conversion work could be carried out at smaller facilities that were not equipped for warship production but could handle civilian-class vessels. The interiors were outfitted using prefabricated components, hospital beds, surgical lamps, tile flooring, and ventilation ducts, assembled almost as if they were parts of a modular building. This approach mirrored the broader American philosophy of the war economy. Anything could be standardized, mass-produced, and adapted for multiple purposes. Beyond the Liberty class, the United States Maritime Commission also allocated newer Victory ships for hospital use. The SS Panama Victory became the USS Haven, AH-12, prototype for a class of purpose-built naval hospital ships that would serve from Okinawa through the Korean War. Each Haven-class ship included climate control, desalination plants, and complete surgical suites, marking a major technological leap. But it was the modest Liberty-class conversions that had demonstrated the feasibility of such transformations. Their success in 1944 and 1945 proved that medical capability could be engineered from the same industrial backbone that had once fueled total war. In historical perspective, the reuse of cargo ships for humanitarian service illustrated a profound duality of American engineering during the war. The same steel, rivets, and blueprints that had built an armada capable of invasion were repurposed to carry hope and healing. The Liberty ships, once symbols of mass production and logistical dominance, became instruments of mercy in the Pacific. Their story stood as a reminder that industrial strength, when combined with moral purpose, could create not only the means to win a war but also the means to save its survivors. The turning point came in the summer of 1944, when the United States launched the Mariana and Palau Islands campaign, a vast offensive that included Saipan, Tinian, and Guam. What had begun as a push to secure airfields for B-29 operations quickly turned into one of the bloodiest sequences of battles in the Pacific. On Guam alone, over 7,000 American soldiers and Marines were wounded, many within the first 72 hours. The tropical heat was merciless. Men lay on stretchers in the open, covered with rain-soaked canvas. Field medics worked without refrigeration for plasma, and infections spread faster than evacuation could occur. Typhoid, gangrene, and tropical ulcers became as deadly as Japanese gunfire. The Navy's existing hospital ships were either engaged elsewhere or undergoing refit, and medical evacuation by air remained logistically impossible. The situation forced a reckoning at the highest levels of command. The U.S. could win battles but lose men to disease and delay. By mid-July, reports from the Surgeon General's office and the Pacific Fleet Medical Division reached Washington. They described scenes of organized chaos, beachheads where corpsmen had to choose which patients would live long enough to justify the precious morphine, temporary hospitals where surgical tents collapsed under typhoon rains. The crisis made clear that the Pacific Theater's medical infrastructure could not keep pace with the tempo of amphibious warfare. Reinforcements and supplies moved faster than the wounded could be treated or transported. Commanders demanded a mobile, protected medical platform that could be deployed close to combat zones and provide long-term care without relying on overburdened island bases. The War Department's initial response was slow, constrained by priorities favoring combat construction. But in August 1944, under pressure from both the Army Surgeon General, Major General Norman T. Kirk, and Navy Bureau of Medicine and Surgery, the Maritime Commission authorized the rapid conversion of several idle Liberty ships into hospital vessels for the Army Transportation Corps. These conversions would not require new hulls or major engine overhauls, only interior reconstruction. The plan was practical, achievable, and urgent. The selected ships, among them SS Zebulon B. Vance and SS Samuel F. B. Morse, were chosen precisely because their hulls were intact and available at East Coast shipyards. Conversion contracts were distributed to major facilities including Bethlehem Four Rivers Shipyard in Quincy, Massachusetts, and Todd Shipyards in New York. Engineers and naval architects worked alongside Army medical officers to redesign the internal layout. Cargo holds were stripped bare, bulkheads cut away, and ventilation systems installed. Special insulated spaces were created for operating theaters and sterilization chambers. Electricians wired new circuits for X-ray units and refrigeration plants, while carpenters built hundreds of folding metal frame beds. The ship's galleys were restructured to serve hospital diets, and their fresh water systems were expanded to meet sanitary requirements. Even the paint became symbolic. Hulls were repainted pure white, with large red crosses on their sides and decks to mark them under the Geneva and Hague Conventions. The speed of the transformation was extraordinary given wartime constraints. Within a few months, the first converted vessels were ready for inspection and commissioning. The USHS John J. Meany sailed for the Pacific in late autumn 1944, its maiden mission to evacuate wounded personnel from the newly captured Philippines and transport them to Saipan and Pearl Harbor. Its success validated the entire concept. Medical staff reported that the ship maintained clean air circulation even in equatorial heat, and that infection rates during transport were dramatically reduced compared to earlier improvised methods. The USHS Jared M. Huddleston followed soon after, proving that the model could be replicated. What began as an emergency reaction to a medical disaster evolved into a coordinated engineering effort spanning multiple agencies: the Army Transportation Corps, the Maritime Commission, and private shipyards working around the clock. The Guam campaign had revealed the limits of even the best prepared invasion force and forced the military to think of engineering not just as a tool for attack but as a tool for survival. From that moment, the notion of converting surplus cargo ships into hospital ships was no longer experimental, it became policy. The same logistical genius that could move armies across oceans was now tasked with saving them once they returned. The catalyst was born not from innovation in design, but from the moral urgency of necessity, a reminder that in war, the greatest technological revolutions often begin with human suffering that can no longer be ignored. The design and conversion process of the Liberty Hospital ships represented a remarkable fusion of industrial pragmatism and medical precision. Each transformation began with a complete structural assessment of the existing cargo vessel. The Liberty hulls, originally designed to carry bulk goods such as coal, ammunition, or machinery, were spacious but crude inside, bare steel frames, uninsulated walls, and narrow passageways. Naval architects and engineers from the Maritime Commission collaborated with medical officers from the U.S. Army Surgeon General's office to redefine the purpose of every deck. Their goal was to create a fully functional hospital environment that met surgical standards while maintaining the vessel's seaworthiness under combat conditions. The first phase of conversion involved gutting the ship's interior. Cargo holds were stripped to the ribs, bulkheads removed, and steel decks reinforced to support new medical equipment. The open spaces were subdivided into wards, operating theaters, sterilization rooms, dental clinics, laboratories, and isolation compartments for infectious diseases. In a typical Liberty conversion, between 350 and 450 patient beds were installed, each equipped with adjustable frames, tie-down straps for rough seas, and individual oxygen and lighting fixtures. The medical layout followed a carefully designed flow. Patients entered through a triage station near the main deck, then moved to treatment wards, operating theaters, and recovery areas deeper within the ship. Mechanical engineers faced the challenge of providing sterile, temperature-controlled air in the tropical climates of the Pacific. Liberty ships had never been designed for air conditioning, but hospital conversions required it. Ventilation systems were redesigned from scratch. High-capacity blowers, adapted from submarine and destroyer spare parts, were installed to circulate filtered air throughout the wards. Refrigeration plants originally used for perishable cargo were modified to store blood plasma and medical supplies. Oxygen manifolds ran through the decks, fed by compressed gas cylinders secured in protected compartments, while steam-driven sterilizers operated continuously in the surgical sections. Electrical engineers added redundant power circuits to ensure uninterrupted lighting in the event of generator failure, a critical safeguard during night operations or emergencies. The conversion also demanded entirely new plumbing and sanitation infrastructure. Hospital ships needed to produce and store large quantities of fresh water for cleaning wounds, washing linens, and maintaining hygiene. Desalination units and expanded freshwater tanks were installed, while waste systems were redesigned to prevent contamination of the ship's living quarters. Kitchens were re-equipped to prepare special diets, and laundry facilities were enlarged to handle thousands of linens per voyage. Even the flooring was replaced. Steel decks were covered with non-slip, antiseptic-coated tiles to allow for rapid cleaning. Attention to detail extended beyond the technical realm. The ship's color scheme and markings were strictly regulated under international law. Once the interior work was complete, painters covered the hull in glossy white enamel, adding broad green bands and large red crosses visible from miles away. The Geneva and Hague Conventions required hospital ships to be clearly identified and unarmed. They carried no offensive weaponry, though they were equipped with blackout curtains and minimal signal gear for navigation. Searchlights, radio frequencies, and even porthole coverings were standardized to prevent misidentification during night operations. To support the movement of patients, mechanical lifts were installed, an innovation for the Liberty class. These electric elevators transported stretchers between decks, reducing physical strain on medical personnel. Every inch of the ship was redesigned with efficiency in mind. Operating rooms were placed near the vessel's center of gravity to minimize the effects of rolling seas. Storage compartments were converted into pharmacies and supply depots. A small radiology department was added, using portable X-ray machines stabilized on shock absorbers to function even in rough weather. Despite the complexity of the work, conversion times remained remarkably short, typically 3 to 4 months from the initial drydocking to sea trials. This speed was possible because the Liberty design was standardized. Shipyards could reuse blueprints and prefabricated hospital components. What had once been a logistical experiment became a semi-industrialized process. When one ship was completed, another would enter the slipway using nearly identical specifications. The end result was a new category of vessel, neither pure warship nor civilian liner, but a mobile medical institution capable of operating thousands of miles from the nearest hospital. Each converted Liberty ship embodied the wartime ethos of adaptability. Its structure was simple, its systems reliable, and its mission unambiguous: to bridge the distance between battle and recovery. The transformation of these ships demonstrated that the same engineering discipline that had built the tools of war could just as efficiently construct the architecture of compassion. When the converted hospital ships finally reached the Pacific in late 1944, they entered a theater defined by both distance and desperation. The first to arrive was the USS John J. Meany, formerly the SS Zebulon B. Vance, followed soon after by her sister ship, the USS Gerrit M. Huddleston, once the SS Samuel F. B. Morse. Their maiden missions began quietly, without fanfare, but they would soon prove indispensable to the medical logistics of the Pacific campaigns. Operating under the protection of the Red Cross emblem, these ships sailed from Pearl Harbor toward the recently secured Philippines, stopping at Saipan and Guam to collect wounded soldiers and Marines. Conditions at the embarkation points were often dire. On Leyte, the beaches and temporary docks were crowded with hundreds of stretchers, the wounded shaded by tent cloths stretched over bamboo poles. Corpsmen moved constantly, carrying patients from landing craft to the hospital ships anchored offshore. Once aboard, the difference was immediate and profound. The air inside the converted Liberty hulls was cooled and filtered, free from the suffocating humidity of the tropics. Nurses recorded body temperatures and infection status. Surgeons began triage operations within minutes of embarkation. The operating rooms, located deep within the ship's reinforced center, maintained stable temperature and humidity even during heavy seas, an achievement nearly unheard of in earlier medical transports. Each voyage served as both rescue mission and experiment. The John J. Meany carried patients from Leyte and Mindoro to Saipan, where permanent hospitals awaited them, and later continued to Pearl Harbor for advanced treatment. On board, medical teams performed amputations, debridements, and transfusions en route, using sterilized instruments and refrigerated plasma, resources that had been impossible to maintain in forward island hospitals. The Huddleston followed a similar route, evacuating casualties from Luzon and Samar during the early months of 1945. Despite the long voyages, sometimes lasting 2 weeks, infection rates and postoperative complications dropped dramatically compared to previous sea evacuations conducted on standard transports. Reports from the Army Medical Department confirmed the success. In official post-action summaries, medical officers noted that mortality during transport aboard the converted Liberty ships averaged less than 1%, roughly half the rate seen in earlier improvised evacuation efforts. The presence of fully equipped surgical wards meant that life-threatening conditions, internal bleeding, peritonitis, and traumatic shock, could be treated within hours rather than days. The ships also provided psychological relief. The white-painted wards, clean linens, and air-cooled corridors offered an atmosphere of calm and recovery far removed from the noise and heat of battle. Many soldiers later described their first night aboard as the moment they realized they would live. Operationally, the hospital ships functioned as part of a larger network of medical evacuation that stretched from the front lines to the mainland United States. Wounded personnel were stabilized on island clearing stations, transferred to the Meany or Huddleston, then transported to Saipan or Guam for additional care before final evacuation to Pearl Harbor or San Francisco. The system depended on precise coordination between the Army Transportation Corps and the Navy's service forces, as hospital ships required safe corridors cleared of submarines and adherence to international signaling protocols. Painted entirely white and illuminated at night, they traveled unarmed and relied on recognition by enemy forces for protection under the Geneva Convention, a fragile trust that was occasionally broken in other theaters but largely respected in the Pacific. The daily life aboard these vessels combined routine discipline with constant tension. Surgeons worked in 12-hour rotations, nurses sterilized instruments after every procedure, and orderlies scrubbed the decks to prevent the spread of tropical bacteria. When seas grew rough, patients were secured to their beds with web straps, and operations continued even as the ship rolled. Engineers maintained the delicate balance of power generation and ventilation. Any failure of the cooling systems risked transforming the sterile environment into a breeding ground for infection. Yet, despite the inherent difficulties, the converted ships maintained consistent performance across thousands of miles and dozens of missions. By the end of 1945, USS John J. Meany had completed more than a dozen evacuation voyages, transporting over 18,000 patients without a single major mechanical failure. USS Gerrit M. Huddleston logged similar achievements, assisting in post-war medical transfers of prisoners of war and repatriated personnel. Their performance validated the conversion program and encouraged further adaptation of surplus hulls for humanitarian purposes. The success of these ships demonstrated not only the efficiency of American engineering but also the resilience of the medical crews who worked within these improvised floating hospitals. In historical hindsight, the field experience of the Liberty-class hospital ships marked a quiet but profound turning point. They proved that standardized cargo hulls could sustain complex medical operations across vast distances, even under wartime conditions. Their endurance reshaped military medical logistics and laid the groundwork for future designs. More importantly, they offered living proof that compassion could be engineered into steel, that a vessel built for war could be remade to preserve life with equal precision. The success of the Liberty-class hospital ship conversions had far-reaching consequences for American military logistics and naval medicine. What began as an improvised response to a crisis in the Pacific evolved into a fully institutionalized program that reshaped how the United States managed battlefield care. The proven efficiency of the Army's converted Liberty ships demonstrated that standardized hulls could be transformed into advanced medical platforms quickly and at relatively low cost. Their performance in the field gave the Navy the confidence to pursue its own large-scale hospital ship program based not on conversions but on purpose-built designs. In late 1944, the U.S. Navy's Bureau of Ships and the Bureau of Medicine and Surgery jointly initiated the development of the Haven-class hospital ships. These vessels were constructed on the Maritime Commission C-4SB-2 hull, a larger and more powerful derivative of the standard cargo design. The Haven-class ships, USS Haven, AH-12, USS Benevolence, AH-13, USS Consolation, AH-15, and their sisters, represented a new generation of hospital ships. Each was over 520 feet long, displaced nearly 15,000 tons, and carried more than 800 patient beds, 12 fully equipped operating rooms, and advanced climate control systems. They were, in essence, floating medical centers capable of sustaining complex surgeries in tropical or Arctic climates alike. The inclusion of air conditioning and oxygen distribution systems throughout the wards marked a revolutionary step in naval medicine. These features had first been proven feasible during the Liberty conversions, but the Haven class refined them to a degree of permanence and reliability that set a new standard for future designs. The Haven ships entered service in 1945, just in time to assist in the final operations against Japan and the subsequent occupation. They anchored off Okinawa, Guam, and Yokosuka, receiving wounded personnel from fleet actions and land campaigns. In August and September 1945, several of them, including USS Benevolence and USS Consolation, participated in the massive humanitarian operation to care for and repatriate Allied prisoners of war liberated from Japanese camps. The scale of their operations was unprecedented. Over 50,000 patients were treated or evacuated during the final months of the war. Their success cemented the concept of hospital ships as essential components of modern naval fleets rather than auxiliary afterthoughts. The influence of these developments extended beyond the Navy. The Army continued to employ its smaller hospital ships throughout 1945 and into the immediate post-war years for the repatriation of wounded and recovering personnel from the Pacific to the continental United States. Meanwhile, the Navy began experimenting with a new category of nearshore medical vessels. Recognizing that large hospital ships could not always operate close to combat beaches, the Navy converted several landing ship, tank, LST, vessels into LST-H, a modified variant equipped with surgical wards, triage facilities, and limited patient accommodations. These smaller ships could land directly on beaches or anchor in shallow waters, providing immediate emergency care within minutes of combat. The LST-H conversions, though crude compared to the Haven class, proved invaluable during the invasions of the Philippines, Iwo Jima, and Okinawa. They served as the first link in a multi-stage evacuation chain that led from the battlefield to the Grand Hospital ships anchored offshore, and from there to base hospitals at Guam, Saipan, and Pearl Harbor. By the end of the war, the U.S. Navy operated 12 major hospital ships and a network of more than 30 LST-H vessels, while the Army maintained 6 converted Liberty Hospital ships. Together they created a comprehensive evacuation and treatment system that spanned the Pacific Ocean. The integration of these medical vessels transformed casualty management from a reactive process into a coordinated, layered system. For the first time, wounded soldiers could receive continuous medical attention from the moment of injury to their return home, a logistical achievement as significant as any military innovation of the war. The impact of this system extended far beyond the immediate wartime context. The Haven-class ships continued to serve during the Korean War, with USS Constellation becoming the first hospital ship to receive casualties via helicopter in 1951, another breakthrough made possible by the lessons learned from earlier conversions. The principles established during World War II, modularity, mobility, and medical self-sufficiency, became enduring cornerstones of military medicine. The experience also influenced civilian maritime design. The techniques developed for shipboard sterilization, ventilation, and patient handling would later inform hospital construction standards on land. In essence, the influence of the wartime hospital ship program lay in its synthesis of engineering and ethics. The Liberty conversions had proven that industrial standardization could serve a humanitarian purpose, while the Haven class institutionalized that vision into naval doctrine. The spread of these ideas across both military and civilian domains ensured that the legacy of those improvised conversions outlived the war itself. By transforming surplus freighters into floating sanctuaries, American engineers and medical officers had redefined the boundaries of what ships and nations could be built to do. In the years that followed the end of the Second World War, the fleet of improvised hospital ships quietly faded from active service, yet their influence endured long after their hulls were scrapped or reassigned. Most of the converted Liberty ships returned to the Maritime Commission, their Red Cross markings painted over and their interiors dismantled. Some were restored to cargo duty, while others were decommissioned and sold for civilian use. The USHS John J. Meany and USS Jarrett M. Huddleston completed their final missions in 1946, carrying wounded servicemen home from the Pacific before being struck from the Army Register. Though their active lives as hospital ships were brief, the engineering and medical principles developed during their conversions would shape naval and humanitarian practice for decades to come. The Haven-class vessels, which had entered service in the final year of the war, became the bridge between the emergency improvisations of 1944 and the organized medical operations of the post-war U.S. Navy. During the Korean War, these ships returned to service in an even greater capacity. They were now equipped with advanced surgical theaters, refrigeration systems, and climate control that allowed them to function continuously in all conditions. In 1951, the USS Constellation, AH-15, became the first hospital ship in history to operate with a helicopter landing platform installed on its deck, an innovation that revolutionized battlefield evacuation. For the first time, patients could be flown directly from combat zones to sterile surgical facilities within minutes. This single technological adaptation linked the lessons of World War II improvisation with the modern era of medevac logistics. Beyond their direct operational use, the concept of converting commercial or surplus ships for humanitarian missions became an enduring standard. The cost-effectiveness and speed of the Liberty conversions had demonstrated that life-saving infrastructure could be created not through entirely new construction, but through intelligent adaptation. This principle reappeared throughout the 20th century. During the Vietnam War, the U.S. Navy continued to rely on converted and refitted hospital vessels, and by the 1970s, humanitarian organizations such as the World Health Organization and Mercy ships adopted similar strategies, transforming merchant hulls into floating clinics capable of delivering medical aid to developing regions. The moral and logistical legacy of the wartime program also extended into peacetime naval policy. When the U.S. Navy began planning for large-scale humanitarian and disaster response capabilities in the 1980s, it once again turned to commercial ship conversion. Two San Clemente-class supertankers, SS Worth and SS Rose City, were selected for transformation into the USNS Mercy, TAH-19, and USNS Comfort, TAH-20. These modern hospital ships, commissioned in 1986 and 1987 respectively, carried forward the same engineering philosophy born in the emergency conversions of the 1940s. Their designers explicitly cited the success of the Haven and Liberty programs as precedents. The Mercy and Comfort retained the essential duality of their ancestors: massive, utilitarian hulls refitted not for combat but for care, capable of treating 1,000 patients at sea and responding to both wartime and humanitarian crises around the globe. The post-war legacy also influenced the relationship between engineering and ethics within the American military-industrial complex. The conversion of weapons infrastructure into healing architecture represented a profound shift in the use of industrial power. During the war, American industry had produced over 2,700 Liberty ships, symbols of relentless output and efficiency. When a handful of those ships were transformed into hospital vessels, they symbolized something different: the redirection of mechanical precision toward mercy. This dual identity, machines built for war repurposed for peace, became a recurring theme in post-war technological development, from nuclear power to space exploration. By the mid-20th century, the idea that ships could serve as mobile humanitarian bases was no longer radical. It had become doctrine. The conversion practices pioneered during World War II informed international maritime law, naval design, and the global understanding of medical readiness. The Liberty Hospital ships, though temporary by design, established the technical standards for patient transport, sterilization systems, and air-conditioned operating rooms at sea. The Haven-class vessels institutionalized those standards, and the Mercy-class ships embodied their culmination. In reflection, the legacy of the wartime hospital ships was not merely technological but philosophical. They embodied the capacity of human industry to adapt under moral pressure, to transform the tools of destruction into platforms of compassion. Their lineage connected the improvised workshops of 1944 to the vast humanitarian missions of the 21st century, from tsunami relief in the Pacific to disaster response in Haiti and the Philippines. In every white-painted hull bearing a red cross, there remained a faint echo of those early engineers who once looked at a rusting cargo ship and imagined not what it had carried, but whom it could still save. The story of the floating hospitals of the Second World War revealed a truth often overlooked in the machinery of war: that engineering, at its core, was never limited to destruction. It was a discipline of transformation, capable of turning metal, motion, and design toward mercy as easily as toward violence. In the darkest years of global conflict, when nations measured progress by the number of weapons produced and tonnage of bombs dropped, a handful of engineers, doctors, and shipwrights proved that the same industrial genius could be used to save rather than to kill. Their work reminded the world that technology carried no inherent morality. It became humane or brutal only through the intentions of those who wielded it. The Liberty ship, born in the crucible of mass production, had symbolized industrial war at its most impersonal. It was the embodiment of efficiency, identical, replaceable, and built to endure risk without sentiment. Yet, when these vessels were refitted into hospital ships, they became something profoundly human. The cold geometry of their steel hulls was reimagined into corridors of care. The same rivets that once secured the holds of ammunition now held the frames of operating tables. Each weld, each beam, each circuit carried a paradox: the machinery of war rebuilt as the architecture of healing. The transformation was not only mechanical but moral, a quiet rebellion against the very logic of total war that had given them birth. To the men who sailed and worked aboard them, these ships embodied a form of redemption. Sailors and surgeons alike described a sense of inversion, the realization that the power of technology lay not in its capacity to destroy but in its capacity to preserve life under impossible conditions. Every successful operation, every survivor carried across the ocean, was a small victory of conscience over chaos. On seas littered with wrecks and oil slicks, the white-painted hulls with their red crosses stood as silent contradictions to the age around them. They declared that even amid mechanized slaughter, compassion could still claim a space, engineered into existence by the same hands that built the instruments of war. In a broader sense, these hospital ships captured the essence of 20th century humanity's struggle with its own creations. The war had proven that technology could amplify destruction beyond comprehension, yet it also demonstrated that the same ingenuity could repair what it broke. The transformation of cargo ships into sanctuaries of medicine mirrored a deeper transformation taking place within civilization itself. The search for meaning in progress, the demand that innovation serves something more enduring than conquest. The Liberty hulls, standardized and anonymous, became floating testaments to the idea that mass production could serve compassion just as efficiently as conflict. When the war ended, the images of these ships faded behind the parades and treaties, but their moral resonance endured. They represented an alternative vision of victory, one not measured in enemy casualties or territory gained, but in lives returned, wounds healed, and futures restored. Each voyage from the front lines to the hospital ports was a passage from destruction to renewal, a literal movement from death toward life. And within that passage lay a profound philosophical statement, that the tools humanity built for war would always retain the potential to heal, if guided by conscience rather than command. In retrospect, the floating hospitals of World War II were not only symbols of mercy but of possibility. They revealed that even at the height of total war, human beings retained the ability to choose compassion over indifference. They proved that design and technology, those hallmarks of modern civilization, could still serve empathy when given the chance. In the calm that followed the war's end, their legacy remained as a question that every generation of engineers would face anew. To what purpose will the next great invention be turned? To build, or to save? The answer, as those white ships once showed upon the horizon, would always define not only the future of technology, but the measure of humanity itself.